Alright, so here we are in the next video in talking a little bit about algebra, just kind of the transition from going from what we were used to in arithmetic to this mysterious mechanical process that we're going to go through in order to find out what x equals. This is called solving an equation. Okay, so let's talk a little bit more about those steps. First of all, let's bring our magic word equation down here, and just for grins and giggles, let's do a little different problem. Let's say I have x plus 7 is equal to 10. Okay, so here's an equation. Well, what does that mean? It means that what is on the left side of the equal sign is numerically equivalent to what is on the right side. Think of it as a balance. In ancient Arabic, and that's where we get algebra from, and that's where the word algebra comes, it means the balance. I'm loosely translating the balance part, but that's basically what it boils down to. Okay. So this is like a teeter-totter or a balance in a laboratory somewhere. This weighs as much on the left as it does on the right. So that's an equation. It must be numerically equal, otherwise it is not an equation. Now, I also like to think of it in terms of this left side over here is the recipe that created this side. And algebra is a way of taking this recipe apart to find out what the secret ingredient is. That's another way to think about it. But I want you for the moment to think of this, though, as being in balance. Because the rules of algebra say that we are allowed to apply any mathematical operator we want, and that oftentimes involves not only the operator but some number, to an equation in order to get down to this final step where it tells us what x equals. We're allowed to do that, apply any of these, as long as we do not upset the fundamental balance of the equation. So if I added 5 to this side, I have to add 5 to this side in order to keep this balanced. If I subtract 3 from this side, I must subtract 3 from this side. Otherwise, I change the balance. If I'm going to multiply something by 3, then I have to do it to both sides, which brings up the golden rule in algebra. Whatever I do to one side of the equation, I must do to the other. Otherwise, I upset this balance, and we're not allowed to do that. Okay, that's key. And this idea of doing whatever we do to one side to the other, this is really what algebra is about. This is the magic behind the door labeled algebra. So how do we go about that? What's the technique? And this brings up another one of the chief complaints that I hear from beginning algebra students in the classroom. They'll tell me, okay, I know how to do this process, but now you got letters in here. I don't understand letters. I don't know how to add letters and numbers together. And boy, I understand that. And we don't actually add numbers and letters together. This is where this stand-in idea that I was trying to explain in the previous video, this X is in here because we don't know what it is, and we're going to go through a mechanical set of steps to where we get to this point at the bottom where it tells us that x equals some value. So, when faced with an equation in algebra, the first thing you want to do is find out, okay, where's the variable? All right, so there's the variable. So this is where I'm going to start in the process of the solving. Because the next thing I'm going to do is say, or ask the question, what is being done to this variable? Well, 7 is being added to it. Well, I need to strip away these operations, so to speak, in order to get x by itself. This is called isolating the variable, if you want kind of a technical phrase for it. We're trying to isolate the variable, put the variable on one side of the equal sign and combine all the arithmetic operations on the other so that we get a number here. But basically what all that is saying is that in order to find out x, I need to undo the operations that are being done to it. That's the process of algebra, undoing the operations that are being done to the x. So if 7 is being added here, I'm going to subtract 7. Let me rewrite it over here so we don't have the balance in the way here. So 7 is equal to 10. So since 7 is being added, I'm going to subtract 7, but I have to do it to both sides. So I get x. 7 from 7 leaves 0, and 7 from 10 leaves 3. Well, we have x on one side all by itself, and a single number over here on the right. There's no other math operations, what I mean by a single value. X is equal to 3. And we know that that's true because this is a simple enough problem, we can solve this in our head without doing any algebra. We know that 7 plus some number equals 10. Well, that number is most likely 3. All right, so that's the process. That's the magic that we call algebra. Basically doing the opposite operation. Here we were adding 7. Let's take another problem. Let's take 2 times some number equals 10. And again, this is a simple enough problem that you can arrive at an answer without going through any formal set of steps. 2 times some number is 10. Well, I know that 2 times 5 is 10. So most likely my answer is going to be 5. Why do I say most likely? Well, there are some occasions where x could be a different value. In this particular case, it's not. 5 is going to be our correct answer. But we'll have to dig more deeply into algebra to find that out, because equations do get more complicated. But what is being done here? Again, in solving this equation, I find the x. What's being done to it? Well, it's being multiplied by 2. How do I undo multiplication? Division is the opposite of multiplication. Just like subtraction was the opposite of addition, division is the opposite of multiplication. When you see a number in front of the x, the implied operation here is that they're being multiplied. Okay, so I'm going to divide, but I must do it to both sides. I'm going to divide by 2. If 2 is multiplying x, I'm going to divide by this. 2 over 2 is just 1, and 1 times x is just x. So these cancel to 1. And x then is equal to 10 divided by 2, and that does get us to 5. So this problem is now solved. All right. The key points is that in solving an algebraic equation, we want to find the x in the equation. We then want to look at the mathematical operations that are being done to it and undo those operations. And in cases where the equation is more complicated, maybe we've got some multiplying and adding and subtracting all going together, and maybe those operations are even taking place on both sides of the equal sign, there is an order in which we undo them. So that'll be explained more in beginning algebra videos. I just want to give you, kind of wrap up the transition of going from arithmetic problem and how that's not that much different than an equation. They come from the same place, and this algebra is undoing these operations that are being done to this stand-in, this thing we don't know. We have an unknown in our equation now that we did not have in arithmetic. Okay, so that's the beauty of algebra, because it works for very complicated equations, where in arithmetic, if we didn't know one of the players, if they were simple problems, we might be able to use our street smarts to solve them. But trust me, in normal algebra equations, we need to do these set of steps. So that's really what learning algebra is finding out what these processes are and getting some practice in doing it. That's algebra. All right. See you in the next video.